Hello and welcome to the second installment in our series on laboratory equipment. My name is Ryan Tsai. In this video, we'll cover the HP E36318 triple output DC power supply. For more information, quick start guides and equipment manuals are available on your course website. The power supply is the voltage source in our circuit diagram. It is a programmable DC power supply, which means, first of all, it supplies constant voltage, and you can program in how much voltage you want it to supply. This arrow means that this value is variable. Our supply has 3 power outputs, which means that it's really 3 sources running simultaneously. This one supplies maximum 6 volts and 5 amps. And these two each supply maximum 25 volts and 1 amp. And they share the common node. This green terminal here is called earth ground because it is connected to a metal stake in the soil near the building. This is different from the grounds in your circuit diagrams, which is not a physical ground but a mathematical convenience. In this introductory video, we'll leave it alone. Here's our triple output power supply. Here's the power button. When you turn it on, notice that the display reads output off, which means that even though the power is on, none of these sources are actually doing anything. Toggle using this button, which reads output on/off. Once the output's on, all 3 of these sources are running. This button is useful when you're wiring your circuit and you don't want any current running through. And it avoids the necessity of shutting off the power and reprogramming all your sources to the correct values, which is a hassle. This is the display. It tells you which source's information you're observing. The +6 volts indicates that you're looking at this source. It does not mean that only this source is running. Remember, either all sources are on or all sources are off. This is the voltage across the source and the current running through it. To see what the program maxima on voltage and current are, press this button here. It reads display limit. You can tell you're on the limit screen by this LMT indicator. If you leave the screen idle for too long, it goes back to the display. Notice that the LMT is gone. This is the maximum voltage and the maximum current. To switch between typing in values for voltage and current, press this button. It reads voltage and current. The flashing digit indicates which one you're modifying, and to switch between digits, use the arrow keys on the right side of the front panel. Turn the knob to adjust the digit. Now, if you want to move to a different display, use these 3 buttons. They read +6 volts, +25 volts, and -25 volts. +25 volts takes you to the display for this source. Notice that the indicator has changed to +25 volts. -25 volts takes you to the display for this source. Now I'm going to build a very simple circuit to demonstrate how to set up the source. We're going to use the +25 volt source. We will have the source in series with a resistor and an LED. The LED lights up whenever current runs through it. Right now the output is off, so there's no current, and the LED is unlit. As soon as I turn the output on, it's going to light up. Now I'm going to explain a feature of the power supply that might be difficult to understand at first, but it's very easy to use. Our power supply can run in either constant voltage or constant current mode, which means that it can essentially operate as either a constant voltage source or a constant current source. We can switch between the 2 modes by playing with the voltage and current limits. Remember that an ideal voltage source delivers constant voltage independent of the current running through it, and that an ideal current source delivers constant current independent of the voltage across it. You can't arbitrarily set both the voltage across and the current running through the source. One is set, and the other is determined by the circuit to which it is attached. Take the circuit for example. It's a 1 volt ideal source in series with a 1 ohm resistor. By Ohm's law, the current through the resistor and the source must be 1 amp. Now say this is a circuit you hook up to your power supply. You want a 1 volt source, so you set the maximum voltage to be 1 volt. Now what about the current limit? Well, we've already seen that the voltage source current should be 1 amp. If you set the current limit to a value greater than 1 amp, then there is no problem. This is exactly what your circuit will be, with your power supply running in constant voltage mode. But what if you set the current limit to be less than 1 amp, say 0.5 amps? Well then this current becomes 0.5 amps, and this circuit as it is doesn't make any sense. Kirchhoff's voltage law is no longer satisfied, unless the voltage across the source becomes 0.5 volts. Now your power supply is actually running in constant current mode, and it's essentially a current source supplying 0.5 amps. Back to the power supply. If you want to set the voltage limit to what you want, say 5 volts, and then raise the current limit until you see CV. If you want to set the current, say to 30 milliamps, set the current limit to what you want, and then raise the voltage limit until you see CC. If you're running CV, it's recommended that you set the current limit to 150% of the expected current, and that if you're running CC, set the voltage limit to 150% of the expected voltage. Most importantly, always keep the current limit as low as possible. 50 milliamps is a good number for most labs. You don't want an error in your circuit to cause a lot of current to flow and damage it. And that's it for the power supply. Remember, if any of the instruments aren't working correctly, or if you have any questions, be sure to let your instructor know. See you next time.